What's going on YouTube? It's the Middle School Math Man. This video is on graphing by intercepts. So we're taking standard form and we're actually going to take it kind of a step further than we did last class. Last class we talked about how to convert from standard form to slope intercept. But now I'm going to show you how you can actually take standard form and graph it. So we're going to be solving for x and y intercepts. So I have a little explanation for how is this done. So first of all, it has to be in standard form. So in order to solve for the x-intercept, what we're going to do is we're going to cover up the y term and solve for x. If we're solving for the x-intercept, we need that x. That's what we're solving for. The y-intercept, we're going to cover up the x term and solve for y. So once we have the x-intercept and the y-intercept, then we're going to plot both of our intercepts, and then we're just going to connect and make our lines. So, if we look at number 1, this equation is in standard form. So what I mean by cover up the y term and solve for x, basically we're just going to kind of ignore this y term. So in this case, my y term is this negative 2y or minus 2y. So basically when we're solving for the x-intercept, we're just going to kind of, ignore that. We're going to cover it up. So I'm going to have 3x equals negative 6. Then I have a nice little one-step equation. So I'm going to get x equals negative 2. So just like that, I solved for my x-intercept. So I'm just going to put a point on x equals negative 2. Then I'm going to solve for the y-intercept. I'm going to do the same thing, except now I'm solving for y, so I'm going to ignore or kind of cover up the x term. So I have negative 2y equals negative 6, divide both sides by negative 2, so I get y equals 3. So I'm going to put a point on y equals 3. And now you only need 2 points to make a line, so we have both of our points. So now we can just go ahead and make our line. That's all there is to it. So number 2, again, if I'm solving for the x-intercept, I'm going to cover up the y, and this was actually easy for us. We get x equals 4, so I'm going to have a point on x equals 4, right there in red. And then same thing, when we're solving for y, we're going to ignore the x, so we're going to get y equals 2. So we're going to put a point at 2 on the y-axis. Then we're just going to go ahead and connect our lines, or our points. So it should look something like that. So at this point, I want you to pause the video, and I want you to try the rest of these on your own. So we just did the first 2. So go ahead and pause them. Try 3, 4, 5, and 6. So number 3, again, solving for x. This one actually works out nicely for us. If I'm ignoring the y, I just have x equals 3. And now if I'm ignoring the x, I have y equals 3. So we didn't really have to do much work on that one. Then we got our 2 points, and once we have our 2 points, we can graph my line. Number 4, so I'm ignoring the 5y when I'm solving for the x-intercept. Really doesn't matter what order you do this in. I always just solve for the x first. That's just, what I do personally. So x equals negative 5, and then now when I'm solving for the y, I'm going to ignore the x, and I get 5y equals 20, so y is going to equal 4. Now I have my 2 intercepts, so I'm just going to graph my line. And number 5, 4x equals negative 4, so x is going to equal negative 1. Let me do this in a different color. So now when I'm solving for y, don't forget that sign in front of it makes it negative y. So I'm going to get y equals 4. So my 2 points are x equals -1 and y equals 4. One more, number 6. We're going to have 9x equals 45. So x is going to equal 5. So when I'm solving for y, I'm going to ignore the x. 15y equals 45, so y is going to equal 3. So there you go. Again, standard form. All we're going to do is just kind of ignore or cross out the y term when we're solving for the x-intercept, and vice versa when we're solving for the y-intercept. So next we're going to talk about special cases. These are vertical and horizontal lines. So vertical lines, we know by now it has a slope that is undefined. So how this is going to work is my equation is just going to be basically the point where the line is going through. So this vertical line, A represents the line's intercept, x equals A is just something you can think about. So in this case, it is going through 3 on the x-axis. So my equation is just going to be x equals 3. Vertical lines are going to go through the x-axis, so my equation, we're always going to have x equals something. Now looking at horizontal lines we know the slope is 0, and they're always going to be going through the y-axis. So we're going to have y equals something, and that's wherever it's going through the y-axis. So in this case, it's going through y equals -1. So if you want to pause the video at this point and try these 6, that's what I suggest. So for number 1, it's going through the x-axis at -2, so it's going to be x equals -2. For number 2, it's going through the y-axis, so we're going to have y equals the point that it goes through, and it's going through 3. Number 3, it's going through the y-axis at -5. Number 4 is going through the x-axis at 4. Number 5, this one's a little bit hard to see, but as you can see, it has like bigger arrows right there, and that's going through the x-axis at 0. Finally, number 6 is going through the y-axis at 2. So these kind of special cases, if you want to call them, the vertical and horizontal lines, just look at what axis is it going through, and then you're just going to have either x or y and whatever that point is that it's going through. So there I gave you the graph, and you gave me the equation. Here for these problems, I'm going to give you the equation, and you guys are going to graph it. I think you can handle this if you would like to try this on your own. But number 7, y equals -5. So it's going to be going through -5 on the y-axis. So there's -5 on the y-axis. And we're going to have a horizontal line going through that point. Number 8 is going through -1 on the x-axis, so that point. So it's going to be a vertical line going through -1 on the x-axis. And I apologize for these lines. Sometimes it's hard with this stylus. Number 9, x equals 3, so it's going to go through 3 on the x-axis, so it's going to be a vertical line. And number 4, y equals 8, so that's going to be a line going through 8 on the y-axis. Finally, just some questions. The first question is, what is the slope of the line y equals 5? Well, if you think about a graph, very rough graph here, y equals 5, that's going to be going through some point up there, and it's going to be a horizontal line going through that point. So we know horizontal lines have a slope of 0. The next question is, what is the slope of the line x equals -2? So x equals -2 is going to be somewhere over there, and that's going to be a vertical line. So we know that vertical lines have slopes that are undefined. And again, x equals 0 is what I'm doing in green here. That is also going to be undefined. So the last question is kind of forcing you to think about, a couple things in these different lines with the special cases. So y equals 3, if we graph that, we know it's a horizontal line going through the y-axis at 3. Y equals 3x is in slope-intercept, has a y-intercept of 0 and a slope of 3. So we're going to rise 3, run 1, rise 3, run 1. So obviously these lines are going to be much different. So adding that x tells us that it's a slope of 3. Y equals 3 is going to have a slope of 0.